All right, I'd like to talk a little bit about the implementation and what that is going to look like. So in looking to develop this, there's really kind of three parts. We're going to have the Jack tokenizer, the compilation engine, and then the Jack analyzer, our topmost module. You'll probably want to call that HJC.py for handle Jack compiler. You may have one more like a token writer or something like that. All right, so in general, the way we're going to use this, we're going to call the Jack analyzer, the Python file that you have, hjc.py is probably the name, and we'll pass it an input. If the input is a single file and ending in .jack, we'll convert that to a XML file. If it's a directory that has a collection of .jack files, we will in turn convert each of those into a .xml file. So in Project 10 and 11, our goal was not to create one single VM file, but rather multiple VM files. So for instance, if we are converting a class that's a point with a method, the complete version of Project 10 would look something like this on the right. We would start by saying that we are in a class. We would then indent by 2 spaces for every level, then start saying what our keyword is, that's a class, to the identifier, which we get that token from our input and its point, we have a symbol, and et cetera. And then we're going to go that we are in a subroutine declaration, move indent. And within that, we can go through each item of those. One thing I will point out here is we have method int getX, that's method int getX, and we have a parameter list, which is going to be right here. You'll notice that the parameter list is empty, but we still do want to show that there is a parameter list in our XML file, and we'll just note that it's empty, and that's fine. So in terms of each of the responsibilities of these kind of different modules, the Jack tokenizer takes care of parsing tokens into their lexical elements, and specifically it's going to take care of keywords, which are going to be things like class, constructor, true, if, etc. The known keywords. If it's a symbol, if it's an integer constant, and that's if our first character is a number, we assume it's integer constant, and that can be anywhere between 0 and 32,767. I will note that negative numbers are represented by a negative symbol, or the minus sign, followed by an integer constant. So in the Jack grammar, integer constants are always positive. A string constant is any set of characters between 2 double quotation marks. That can be tricky to take care of because you can have multiple keywords and symbols that are a part of the string that are not a part of the known keywords to the Jack. In other words, we can have a string that includes something like let, and that's just a part of the string. It is not a lexical element that we want to then start parsing. So just keep track of that. It gets a little bit tricky trying to determine string constants. And then lastly, identifier, and that's something that the developer or user supplies, and that's any sequence of letters, digits, and underscores. These are things like class names, variable names, etc., any user-supplied name. So the compilation engine, that will take care of the program structure, statements, and expressions. So in other words, the tokenizer is responsible for getting the raw tokens and representing what type it is. And then the Jack compilation engine, that is responsible for understanding the grammar and knowing that it's compiling a class, and there's a certain sequence of expectations that there needs to be for that class to be valid, and then to kind of then parse through the known tokens to understand it and represent that grammar in a hierarchy. So if we look at what we are outputting in Project 10, there's essentially 2 sides to that. On the left is the complete XML output for what I just showed you. And that includes all of the hierarchical structures and elements such as class, subroutine declaration, parameter list, subroutine body. It is understanding how the code is structured because it knows the grammar of the Jack language. The first step you'll use to get there, though, is just going to be emitting the tokens only into an XML file. And that's more what's shown on the right. This is including indentation too, just so you can see the difference. But this is just starting, this is just starting. There's a keyword class, there's an identifier point, there's a symbol, the curly brace, there's a keyword method, there's a keyword int, etc. Just going through. And so the first step is, of course, to know then what is the token I have and what is the type of that token. So within the compilation engine, the way we're going to achieve some of this, the compilation engine is going to be aware of these tokens, and it's looking for the specific grammar. So we are going to implement different functions such as compile statement, compile if statement, compile while statement, And they're going to implement these rules over on the right. So for compile while statement, we'd of course want to see while, want to see an open paren. We then call compile expression. Once that returns, we'd look for then a close paren. We'd look for now a curly brace. Then we call compile statements. And lastly, we'd look for the ending closing brace when compile statements returns. And compile statement, of course, it's going to call other various functions within that. So each function is going to compile each item of the Jack grammar. And that's kind of what I just talked about right there. There are some rules in Jack grammar that do not have a corresponding method. Those are kind of shown on the left, and for these the logic is quite simply just handled by the rules that you invoke. So for instance, compile statements. That is going to use a loop to handle 0 or more statement instances according to the left-hand rule. So if the leftmost token we get within a compile statement is if, while, etc. So if it's an if, we're going to call compile if. It's a while, we're going to call compile while. And so we're going to keep doing that until we are done compiling statements. So there's no real compile statement method. It's just that compile statements handles compiling all these. You don't need to write two separate ones, I guess what I'm saying. So in other words, don't get too overburdened by having to have individual methods for all these. You can reuse some that you have. The topmost main module, that's going to handle the input, getting the output file ready, and for each of the files that we want to compile, each individual file, we'll have a tokenizer that's going to come from the Jack file. And we're going to create an output file named whatever it is, .xml, prepare it for writing. And then we're going to use a compilation engine to then compile the input using the tokenizer and write that to our output file. So kind of the summary of what we're doing. If we have this Jack file, so I'm showing test class.jack with some elements in there. The first step that you want to do is just show that you can understand the tokens. We don't care about the grammar yet. Just create the tokens. And that we will show by writing to a test class capital T.xml. So anything that ends in T, this capital T, that is only the tokens. So the way we do that is we open our tokens tag, put 2 spaces, write all of our token types, the token itself, close the tag, go to the next line. These are all indented by 2 spaces. At the end, we then will close our tokens tag. One interesting item, I guess, here it is, to keep track of. These particular symbols, to be valid XML, we need to convert them to these symbols at the bottom, and that's just one thing you'll need to do within that. You're writing to the .txml file. So, first step, write all of the tokens. Token type is a tag, the token itself, then followed by the token. This is an example of the less than symbol. That's the showing that your tokenizer is able to understand and parse the tokens. The next step, the complete program for Project 10, would be to write the fully structured XML file. And this is kind of what we've shown you before. And this is showing what that might look like. So if we were compiling a let statement, we'd have let statement, keyword, identifier, symbol, then we'd have expression. Well, expression has terms, and we have finally the identifier X. And that's going to be done through your compilation engine class that you need to write. In the skeleton files that we've given you on Moodle, you have access to the input, the main HJC file. The main file is going to open up the directories, get everything ready, and it's going to pass that to a function called process. And so you need to then work with the tokenizer to create the tokens, and you'll need to create a compilation engine class, which can then start parsing and understanding the Jack grammar. One other way or thing to mention is testing these files is much simpler than in previous projects, because we've given you the expected XML outputs for each of these. And so as you are running and compiling your code, you can write your Python code to do this parsing, write to the output file, and then look and compare the expected output versus your output. Be careful not to write over these. And then you can see where the differences are, what's going on, and it's very iterative the way you can develop this to make sure that you're doing the right thing. And then last thing is that there are, to help you, expressionless versions of these files that do not have nested expressions, and they, from a sense of the actual program itself, are meaningless, but they're there to help you in testing. So let me pull one up and show you what that looks like. All right. So what these are is these are showing you what the expressionless files look like. So in this, we have a square class, and there's various parts of it. But what I'm doing now is I'm highlighting the expressions. So you can see all of these arguments and parts that are going inside of this if Boolean. Size plus 2, y greater than 1, all those expressions. What we've done is then created an expression-less version. So now you can see if x, let size equal size, if y. And that's there to help you not have to worry too much about some of the recursive elements and just go through and after you have the tokens, you can run on the expressionless versions with your compilation engine to see how things are working. And this is your the purpose is so that you can test the analyzer's ability to parse everything except for some of these expressions. So here's what the expressionless might look like. Let x equals x. You can then run that into your XML file, and that lets you know if it's working. So this is meaningless in terms of what the code is, but grammatically it is still valid, and that's for you to check. So anyway, there you go. You're going to take the Jack file. You can use the skeleton files that are provided. You need to then be able to go through all the tokens, write those to the tXML file. Then you can start working the compilation engine to understand and parse the Jack grammar itself and understand that hierarchy. Work the expressionless files, and by the end, you will have the fully working compiler going, and you can now take Jack code and understand the full syntax and grammar and hierarchy of what that code is actually meaning.